solve. So for this equation here, number g, we need to put our logs together in terms of a single log on each side if necessary. But we only have logs on one side here, so we just got to put those together. And since we have the plus here, that's the product rule. So this would result in the log base 3 of x plus 1 times x plus 4 and equals 2. So now I'm going to multiply those together. This is going to give me the log base 3 of x squared plus 5x plus 4, and that equals 2. So now, once I get to this place where I have a single log equaling a number, I'm going to use that equivalence property, and I'm going to turn it into an exponential equation from there. So it's going to be the base, to the other side, to the power of the other side. So that's going to be 3 squared, and that's going to equal x squared to what I'm taking the log of, x squared plus 5x plus 4. And then this is going to give me a 9 here, so 9 equals x squared plus 5x plus 4. Now once I see this squared here, that tells me right away that I have to get everything over to the same side. So I'm going to subtract the 9 over to both sides here. So now I'm going to get x squared plus 5x minus 5 equals 0. So to find the solutions for this equation here, I'm going to use the quadratic formula. So that means a equals 1, b equals 5, and c equals negative 5. And then I'm just going to use the quadratic formula. So x equals negative b, which is negative 5, plus or minus square root of, and I'm just going to write 25 in there because it's b squared, and then minus the 4 times the a, which is 1, times the c, which is negative 5, all over 2a, which is 2 times 1. Then I'm going to simplify this, and if I look at the inside of this square root here, then when I have that 25 minus 4 times 1 times negative 5, that's really 20 that I'm going to be adding because 2 negatives is a positive, so that's actually a plus. So it's going to be negative 5 square root of 45. And then that's going to be over 2. And then what I'm going to do next here is when I look at that 45, that can be simplified. And I can call that 9 is a perfect square of 45. So I can say 5 plus or minus 3 square root of 5. And that's all over 2. Now, where I'm going to go from here is I want to now do the approximations of those decimals. Of those radicals, because that doesn't really help me to find out what is a good answer here. So I have x equals, and not equals, let me use approximation here, because it's just an approximation. So when I take the negative 5 plus the 3 square root of 5, that number is going to result in 0.8541 blah blah blah, and the other number, when I plug in the negative 5 minus the 3 square root of 5, that's going to be approximately negative 5.8541 blah blah blah. And the reason why I'm bringing this up, because remember where I started at in this, I cannot take the log of a negative number. So now if I take this 0.85 and plug it in for x up here inside of these logs here, it's going to remain positive. And I don't really care what the number is. I just care that it stays positive in there because then I can use that for a solution. So what that tells me then is this number here will stay positive when I plug it in. So that's a good number. And I'm going to write the exact value for that when I'm done here, but I want you to understand that that number will work. And then when I look at the next one here, this negative 5.85, when I plug that negative 5.85 in here, that's going to give me a negative number, and I can't take the log of a negative number, so that answer can't work. So what that means for me then is that means when I look at this answer here, I have to take the negative away. And only the positive one is going to be true. So that's my answer. If you notice, I took the minus away from underneath because that one can't work. So that's in general what I'll have to do for my test or your quiz, whatever you decide to, whatever I give you this problem on or a problem similar to this. If it turns out to be a radical for an answer, for a solution, you have to find the decimal approximation so then you can further verify that it's actually a solution or it's not a solution. If you don't show that step, then you'll lose points for that, for sure. So this is the only answer that's true for this one, even though I had two answers. And also on this problem here, make sure you use the exact answer for your solution, not the approximation. So for the next problem now, we're going to do a similar idea because these two have to go together. And since this is a minus, I will be using the quotient rule. So this is going to turn out to be ln of x minus 2 over x. And that's going to equal the ln of 54. So now that we got this to one log on each side, and that's the most we'll do ever is a log on each side, or a log and a number like we did on the other side. We got down to a single log and then a number. So any one of those two instances when I'm dealing with log equations, that's where I want to be. So now I can take each side of this and plug it in e to the x. So this is really going to be e to the ln of x minus 2 over x equals e to the ln of 54. So now we can see that those are going to just cancel. And I'm going to get x minus 2 over x equals 54. So I actually have to plug those into the exponential function in order for those to cancel. Okay, so now I'm here, I multiply both sides by x because now we're in algebra land. And we definitely know algebra. So this is x minus 2 equals 54x. And I'm going to subtract the x. So negative 2 equals 53x. So then I'm going to divide by 53. So my x is going to equal negative 2 over 53. So hopefully you guys notice here that, remember, I need to plug this into any one in the top, and if I get a negative that I'm taking the log of, then I can't use it. And I can take this negative 2/53, and I can plug it in this first one here. And a negative minus a number there is going to give me a negative. So therefore, I can't use this number. Even though it worked out algebraically, it introduced an answer that I can't have. So for this, I would write no solution. And this is why it's important for me to check. And if I don't, you'll definitely lose points if you guys don't check your work. These are necessary to check. All right, so there's your answers.